Hello everyone, my name is Rajat Ayal. I'm a TME with the wireless team focusing on Mobility Express. In this session, I'm going to give you an update on AireOS 8.7 features that are going to be introduced on Cisco Mobility Express. In terms of the session agenda, I have 3 topics to cover. I'm going to give you a quick recap of the journey on Mobility Express. Then I'm going to talk about the APs that support Mobility Express. And then finally, I'm going to give you an update on the AireOS 8.7 features. So let's get started. We introduced the solution back in 2015. And there are 2 things that I would like to highlight on this slide. Number 1, I would like to highlight some of the key features that were introduced in the past releases. And the second thing that I would like to highlight is the fact that the BU is committed to making investment in the Mobility Express solution. And looking ahead, we have 8.7, which is going to go out anytime now. It is packed with features on Cisco Mobility Express. And we will talk about all these features in the coming slides. Looking ahead into 8.8, there are going to be some key features that are going to be supported on Mobility Express, starting with DNS support for Bonjour and Chromecast. We'll support video streaming. We'll have features like scheduled RLAN, RFID tag support, DNS-based ACL rules for post-auth ACLs, EOGRE support, and finally option 43 support from Mobility Express. Let's take a look now on APs that support Mobility Express. So this is basically the indoor access point portfolio, starting with 1815 all the way up to 3800. And as you can see here, all these APs support Mobility Express, which means that all of these APs can run the controller function. The difference between the APs here is just the scale. Okay, so 1815 or the 1800 series APs support 50 access points, 1000 clients, and 28 and 3800 series APs support 100 APs and 2000 clients. But in terms of the feature parity is exactly the same across these APs. In terms of the outdoor access point, Mobility Express is supported on 1540 as well as 1560. And in terms of the scale, 1540 will support 50 access points, 1000 clients, and 1560 will support 100 APs and 2000 clients. Let's now take a look at the interoperability matrix for Mobility Express. So in AireOS 8.7 release, we recommend using ICE 2.2. And with respect to Mobility Express support in DNS Center, DNS Center 1.2 will support a limited set of features and will be EFT quality. With DNS Center 1.3, we will have support for both automation as well as assurance. With respect to CMX, presence, location, engage, all of them are supported with Cisco Mobility Express. All right, so let's take a look at the 8.7 features, starting with optimal AP join. So the use case for optimal AP join is quite straightforward. So customer has a Mobility Express deployment and they're trying to add another AP to it. The challenge is that the AP that they're trying to add has a different software version than what is running on the controller. So what this feature does is it enables a CapWeb or Mobility Express AP to download the ME code from another AP which is present in the network at the time of AP join. And the prerequisite for this feature is that the AP that you are trying to join, the same model must be present in the Mobility Express network. The biggest advantage of this feature is that it eliminates the dependency on an external server to provide the code at the time of AP join. In terms of the AP models that support this feature, in 8.7 it is supported on 2800, 3800, and 1560. For all the remaining Wave 2 APs, this feature will be supported in 8.8. One thing to note here is that this feature is not supported on Wave 1 APs, so 1700, 2700, and 3700 would not support this feature. Let's take a look at this in a visual form. So what we have here is a 5 AP deployment running 8.7 code. So we have a 3800 series AP, which is running the controller function. Then we have a 2800, an 1850, an 1830, and an 1859. So let's say we add an AP to this network, and it happens to be a 2800 running 8.6 code. So prior to 8.7 release, if this AP, the 2800 AP that we just added, has to join this network, it has to download the 8.7 code from an external server. And that external server could be a TFTP server, or it could be Cisco.com. But starting at 7 and with the optimal AP join, what's going to happen is, because there is another 2800 present in the network, the 2800 is going to send the 8.7 code to this AP, and after it receives the code, it will go through a reboot, and after it comes back up, it will run the ME code and will join the network. So the next feature is SFTP transfer mode for software update. So the use case is that you have a multi-site ME deployment and you want to perform software update over WAN, but the challenge is that the WAN links are quite slow. So prior to 8.7, we supported HTTP, TFTP, and Cisco.com as a transfer mode. Starting with 8.7, we are adding support for SFTP as well. And what SFTP does is that for slow WAN links, it significantly improves software download, both in terms of time it takes as well as reliability. The other thing is that SFTP is secure and it's TCP based. Now, with respect to some of the lab testing that we did with SFTP, we had a 65 AP deployment. It was a mix of 2800 and 1815 series APs, and the WAN link was about 1 Mbps. So with this setup, it took around 15 minutes to do a software update. So we have yet another enhancement around software update. And the use case here is that the customer wants to bring up single or multiple sites using network plug and play. And in addition to bringing up the site, the customer also wants to perform a software update during the site bring up without having to manually initiate the software update afterwards. So how do we accomplish this? So what we have done in 8.7 is we have enabled functionality on the ME device side, which would trigger software update to be performed using SFTP at the time of site bring up. Now the prerequisite for this is that the software update trigger has to be present in the ME-WLC configuration file, which gets sent from the PNP server, and it must also have the SFTP server details. In addition to that, the SFTP server must have the code to which the upgrade must happen. So let's take a look at how this works. So here what we have is, we have an SFTP server, which is hosting AireOS 8.8 AP images, for example. We have an AP with 8.7 code, and we have APKM server over WAN, which has the PNP application, and the PNP application has the configuration file. So when we boot up this AP and it comes up, it fires the PNP agent. And when it fires the PNP agent, the PNP agent initiates a connection to the APKM server, to the plug-and-play service, and the plug-and-play service would send the controller configuration file back to the master AP. This configuration file has the trigger for the software update. So what happens next is that the software update is triggered using the SFTP parameters that are also part of the configuration file, and the SFTP server in response sends back the code to the master AP. The master AP then upgrades to 8.8. Once the master AP is upgraded, the remaining APs also download the code from the SFTP server. So the next feature that I want to talk about is DNS Pre-Auth ACL Support. So the use case here is that of a walled garden. And if you go to a hotel, for example, Hilton.com, when you connect to the guest Wi-Fi, you are presented with a splash page about the property. At the same time, you may have access to Hilton.com, and you may also have access to their booking system, for example. So what walled garden does is it allows hotels or hospitality customers to selectively allow URLs of their choice prior to the authentication of the client. And the second use case is that if you want to integrate social logins with guest splash pages, you have, let's say, for example, Facebook, you have to allow the authentication request to be processed by the Facebook servers. So there you would need to allow certain URLs that are required for processing the authentication request for Facebook. In terms of the feature support, we supported IPv4 pre-auth ACLs prior to 8.7. In 8.7, we are adding support for DNS-based ACLs as well. In terms of the rules, we support both actions, permit and deny, and wildcard matches for domains, for easy subdomain match is also supported. In terms of the scale limits, total number of DNS rules per ACL is 20. Maximum number of characters in DNS URL is 255 characters. And in terms of the IP ACLs, Mobility Express supports a total of 32 IPv4 ACLs and 64 IPv4 rules per ACL. So the next feature is bidirectional rate limiting support. So the use case here is that of coffee shops, hospitality, airports, public areas, where a company can offer a free low throughput service to everybody and charge users for high throughput service. So the way this works is that this feature adds the ability to configure upstream and downstream throughput limits on the wireless network. And these limits can be applied in three places. It can be applied per WLAN, on a per BSSID basis, which is a combination of an AP radio and WLAN, or on a per client basis. And in terms of the implementation, upstream and downstream rate limits are enforced on the access point in Mobility Express, because Mobility Express does local switching of data traffic, so the enforcement is at the AP. Upstream and downstream per client limit is enforced first, followed by BSSID, and finally WLAN. What that means is that if you have bidirectional rate limits configured for all these three, then the client rate limit is going to be enforced first. Also, we can have AAA return airspace QoS attributes, and they will take precedence over what is configured on the WLAN. Please remember that rate limiting works for TCP and UDP traffic only. It doesn't work for CAPPAP or EOGRE traffic. In terms of the configuration from the web UI, it is available under the WLAN traffic shipping tab, and it is available both in standard view as well as the expert view. In standard view, you have a slider for the upstream and downstream parameters, and in the expert view, you have additional real-time parameters that you can rate limit by entering a value. We are also adding support for client limiting. And the use case here is that the customer may want to limit the number of clients that can connect to a WLAN. And this is to ensure that the WLAN bandwidth is used efficiently in the network. And the second use case for client limiting could be at the AP radio. And the use case there is that the customer may want to uniformly distribute client load across the AP radios for optimal use of RF bandwidth. So this client limiting feature is supported on a per WLAN basis, and it is also supported on a per radio basis on an access point. Now, in terms of configuration, you can configure these limits on a WLAN under the Advanced tab and enter a value for the maximum allowed clients between 1 and 2000. You can also select a value from a drop-down list. And in terms of limiting the number of clients that can connect to a radio, you can enter a value from 1 to 200 for the maximum allowed counts per AP radio. So the next feature is AAA override support on WLANs. And there are a few different use cases here. The first use case is that of a AAA return VLAN. So let's take an example of a school. So school has a school Wi-Fi, and in the school you have teachers and you have students. So when students connect to the school Wi-Fi, they get placed on, let's say, VLAN 20. But when the teachers connect to the school Wi-Fi, they get placed on VLAN 10, and these VLANs are coming back from the AAA. And the reason why a customer would want to do that is because they want to segment teachers from students, what access they have in the network, and things like that. So let's take another use case of a multi-site deployment with different VLAN schemes at each site. So there, one can use AAA to return a VLAN name instead of a VLAN ID to onboard the clients. And the way to understand this is, let's take an example of a school district. The school district has two schools, School A and School B, and there is a central radius server which is serving both these schools. So you have teachers and students in School A, and you have teachers and students in School B. So when teachers in School A connect to the SSID, instead of returning the VLAN ID from AAA, this time we are going to return the VLAN name, and let's say VLAN name is also teachers. So when VLAN name teachers get returned from the AAA server, on the device itself, there's a mapping of teachers to a VLAN ID, and let's say it's 10. So on site A, teachers get placed into VLAN 10. Now when we go to side B, there the teachers could be mapped to VLAN 20. But when teachers inside B connect, they still get the VLAN name returned from the AAA server, which is teachers. And because inside B, the VLAN name to VLAN ID mapping is different, the teachers are put in the VLAN that are specific to that site. In terms of the device configuration, the AAA override must be enabled on the WLAN. For AAA override of WLAN, the VLAN which gets returned from the AAA must exist on the FlexConnect APs. So what that means is, if there is a VLAN that is coming back from a AAA server, you must make sure that it exists on the FlexConnect APs on Mobility Express. For AAA override of VLAN name to VLAN ID mapping must exist on the FlexConnect APs. So for example, if you are mapping teachers to VLAN 10, this mapping must exist. So when AAA returns VLAN name teachers can get placed into the right VLAN. In terms of the configuration, you can go to WLAN under the Advanced tab. There is a toggle for Allow AAA Override. Now in terms of the AAA return VLAN name to VLAN ID mapping, you can once again go to the WLAN, and under the VLAN and Firewall tab, you can create a mapping between VLAN name and VLAN ID. So the next feature is RLAN support for wired ports. So the use case here is that you have these purpose-built access points like the wall plate APs, the 1815W and the 1810W, and they have Ethernet LAN ports. And these access points are typically deployed in dorms and universities and hospitality space. So the idea is the customer would actually connect an IP phone, a set-top box, etc. to these wired LAN ports. So RLANs enable connectivity of wired clients to these LAN ports. Now we also have aux ports available on other APs like the 2800s and the 3800s. They don't have wired LAN ports, they have aux ports. You can use RLANs to manage those aux ports as well. So once again, if there is a need to connect a device, let's say a camera, to the aux port, you can enable that aux port using RLANs. In terms of support on Mobility Express with respect to RLANs, please note that a maximum of 16 RLANs are supported. RLANs do support 802.1x, open and guest authentication. MAC filtering is also supported. AAA VLAN override is also supported on RLANs. And in terms of switching of data traffic, please note that the wired LAN ports would switch traffic locally in case of Mobility Express. So the next feature is Central WebAuth. So Central WebAuth has been a long-standing ask from field, from you guys. And the use case here is that for multi-site deployments with Mobility Express running at each site, customer has to manage guest onboarding, network access control, and WebAuth certificate on each WLC. And if the number of sites is quite big, this can pose a challenge. So what Central WebAuth does is, Central WebAuth allows customers to centrally manage certificates, guest onboarding, network access control using ICE or Radius Server. So Central WebAuth happens at layer 2 and layer 3. And in Central WebAuth, the redirection URL and the Pre-Auth Web ACL are centrally configured on ICE and communicated to the WLC via Radius. In terms of the configuration, what we have done on Mobility Express is we have sort of simplified the CWA configuration. We have added a security type as Central WebAuth on the WLAN. And what that does is at the back end, it automates the necessary configuration that is required for Central WebAuth. For example, enabling AAA override, iSNAC, redirect ACL creation, change of authorization. All of these are automatically configured when you select Central WebAuth as a security type. So the next feature is the ability to import an OUI file on ME controller from the web UI. And the use case here is quite simple. So ME-WLC has a built-in library of OUI signatures, but new devices on the market keep coming up. And to accurately identify these devices on the controller, one can upload a new OUI file with the latest signatures. So what you can do is you can download the latest OUI file from IEEE, or if you have your own, and you can upload this file onto the controller. And what that will allow you is, it will allow you to identify those devices based on the signatures on the controller. So we're also enabling ability to import EAP device cert on the ME controller from the web UI. And the use case here is quite simple. The WLC uses EAP methods for authenticating the clients. So the customer wants to use EAP TLS, they have to import a certificate. And prior to 8.7, we could import certificates using CLI, but in 8.7, we are adding this capability from the web UI as well. Passive client support. So what are passive clients? So customers have these wireless devices such as printers, scales, etc., which are statically assigned an IP address. And these devices do not transmit any information such as IP address, subnet mask, or gateway when they associate with an access point. And therefore the challenge is that the controller never knows about them. So by enabling support for passive clients, basically we are enabling the broadcast of ARP requests, and the APs respond on behalf of the client. And in terms of the configuration, passive clients can be configured under the advanced tab. There is a toggle for passive clients, so you enable that, and then you enter the multicast IP address. One thing to note here is that passive clients is not supported on guest and central WebAuth WLANs. So this brings us to the end of all the features that are supported for 8.7 release. I also want to share with you one more thing, and we get this request from you guys quite a lot. What is the largest Mobility Express deployment, or how stable is it, right? So what we did was we deployed Mobility Express at scale in Building 24 in San Jose, and we had 100 APs in the Mobility Express deployment. So this is a snapshot of the controller, the Mobility Express controller dashboard from Building 24 not too long ago. It is running 8.7 code. It had 100 APs, and at the time I took the capture, we had 945 clients. These are active clients on 5 gigahertz. This controller, Mobility Express controller, is configured with 3 SSIDs, but mainly we were using 2, Blizzard and Alpha. So Blizzard, as you know, is a corporate SSID. And based on the snapshot, we actually have about 722 clients on Blizzard and about 221 on Alpha. AVC and local profiling was turned on. You can see all the operating systems of the devices shown here. And we ran it for about 14 days without any issues. So I wanted to put this thing out for you guys. If you have any doubts in terms of whether or not Mobility Express can run at scale, can it run in a real environment? So, this is really a proof that it is actually quite stable. And with all the new features that we're adding on the solution, you guys should feel comfortable positioning this solution with the customer.